We regress earnings on female, age, age square, college and high school. So earnings over here is the dependent variable, and female, age, age square, college, high school, these are your independent variables. The information on education is available in 3 dummy variables indicating elementary, high school or college education. What would be the main problem if we would add elementary to this specification? Well, the answer is going to be quite straightforward. The problem is going to be perfect multicollinearity, or in other words, it is going to be dummy variable trap. Okay. However, let me spend some time explaining this. So this is either perfect multicollinearity or it can also be called dummy variable trap. Okay. So let's see how is it going to work. Well, the rule is that if you have a variable, so if you have a qualitative variable, which in this case is education, and education has 3 dummies. Okay. So one is elementary, the other one is high school, and the third one is college. Okay. So the rule that we have is that if a qualitative variable has information available in 3 dummy variables, then to avoid perfect multicollinearity or dummy variable trap, you have one of these 2 options. So your option number 1 is keep the intercept term, which is beta 0. So keep the intercept term, which can also be called constant term, by the way. So keep the intercept term or the constant term, whatever you want to call it. Either way, it is denoted by beta 0, and 2 out of 3 dummies. 2 out of 3 dummies. Okay, so you have to take 1 dummy less. So this is your first option available if you want to avoid perfect multicollinearity. Which 2 dummies you choose out of the 3 dummies available, that doesn't matter. So in this case, they have taken high school and college over here. So they have not taken elementary. So this model is fine. Okay, because they have taken intercept term and 2 dummies out of these 3. They could have chosen any 2 dummies. It doesn't really make a difference. Okay, so that's your first option, that if you want to avoid perfect multicollinearity, this is what you should do. The option number 2 that you have, that if you want to take all the dummies, then you have to remove the intercept term. So that means to not take your beta 0 in the model. So you have to remove the intercept term beta 0 and keep all 3 dummies. Okay, keep all 3 dummies, right? And these are the rules to avoid perfect multicollinearity. So to avoid perfect multicollinearity, you have to remember these 2 rules. If you want to keep the intercept term, leave 1 dummy out. Okay. If you want to keep all the dummies, leave the intercept term out. You cannot have the intercept term as well as all the dummies. Okay. If you keep the intercept term and all the dummies, you will fall into this dummy variable trap, or in other words, perfect multicollinearity. And that's what they are asking you in this question. What would be the main problem if we would add elementary to this model? So over here in this model, if you add elementary also, so let's say we do plus beta 6 elementary, then what is the problem that we are having over here? Well, you do have the intercept term also, and you have all the 3 dummies also. This is something you can't do. If you want to add elementary to this model to avoid perfect multicollinearity, you will have to get rid of beta 0. Okay. If you do not get rid of beta 0, you will have perfect multicollinearity, and that's what's happening in this question. So the main problem that you will have is perfect multicollinearity, or they can also call it dummy variable trap in this case.